So in this clip, I wish to go over how to find the second order derivative. And some of you mentioned the notation. Yes, you need to know both the prime notation and the Newton-Leibniz notation. Okay, typically it's written as dy dx, which is the same. And of course, we need to specify what y is. And the second order derivative has also has a a notation, which is derivative of the first order derivative is second order derivative. Okay, in this example, we're going to show you how it's been expressed. Okay, so we get the this is second order derivative. Okay, dx squared. And we are going to use more and more the second, the new notation. And you must get used to it because we're going to get started on A rule next week. All right. First order derivative. We've done quite a few of first order derivative. And in this case, we got the function, right? So we're going to apply this definition. First of all, we're going to work on the first order derivative. So f of x is such, right? And f of x plus h will be the input. Everywhere x will be substituted by x plus h. And then we're going to make the quotient. Before we make the quotient, it might be easier that if we just work on the numerator, which is the difference in the numerator. So we got f of x plus h subtracting the other one. And don't forget to put a parentheses, because without it, it's going to be a mistake. Okay? So once again, we're going to do some algebraic manipulation. So subtracting, this is going to be plus, and we're going to do some regrouping. Remember, our goal is to, isolate, so h will be a factor. We know that for polynomial, this is going to be worked out, right? So we don't have to, make it so expanded, right? Because sometimes when it's so expanded, it gets really complicated. It's very easy to make mistakes. So if you can see things in a certain way or learn something to improve your algebraic skill, you can avoid a lot of mistake. And on this latter part, of course, we're going to deal with this part, okay? And we're also going to deal with the other part. So obviously, we're going to have minus 3x minus 3h, right? So this is minus 3h. So negative 3x and positive 3x will make 0. So that part is easy to fix. And on the first two terms, I would just try to keep things simple, okay? So it's going to be a to the power 3. So by this time, we are pretty familiar with it, right? These algebra things is the more you do, the better you're going to be. And b to the power 3, sorry about that, equals to a minus b multiply a squared plus ab plus b squared. Check that formula if that works, okay? I think it works. If it doesn't, you can just look it up, right? Look it up or derive it and make some adjustment yourself, okay? These algebraic issues can be resolved. So what I'm going to do here, I'm going to apply this formula over here, okay? So I'm going to get a minus b, which is x plus h minus x, multiply this latter part, right? This latter part. So I'm going to put it right here. Okay, so let me make some more space for ourselves. So a squared, obviously, a is x plus h, right? A is x plus h. B is x. And b is x, right? So we apply the formula. Okay, I'm doing this on, you can do this on scratch paper, really, if you have any doubt, okay? I'm just trying to get this finished and not make it too long. So I got this part. By the way, you can FOIL to your heart's content, okay? You don't have to do my way, okay? I don't claim my way is the best way. And now by this time, negative 3x and positive 3x have already reduced. And over here, look at here. Look at this part. This will make h, right? We have a bracket here. We have h here. We have h here. So the h can be factored out. H can be factored out. Okay? So that everything in the bracket will stay, right? We don't have to FOIL them all. And subtract 3. Subtract 3. So now we have worked out the numerator. And the numerator has become h multiply something that we know if we put in the quotient. And we're going to reduce the h. We're going to reduce the h. Right? So we got right there. So we're going to replace the numerator by the simplified form. H and h will be reduced. H and h will be reduced. And the bracket can be open. The bracket can be open. In fact, we can omit the entire denominator, which is 1, right? And put in the parentheses or bracket if you want. And next is just a direct substitution. So direct substitution, we are getting, replacing h by 0, right? By 0. And what do we get? We get 1x squared, 2x squared, 3x squared. So we get 3 times x squared. Okay, minus 3. So that's our first order derivative. So we got our function and we got our first order derivative. We don't have a domain issue because the function is a polynomial function. Polynomial function is differentiable everywhere. Okay, so next we're gonna do, whoops, did I delete something? Okay, I'm okay. Now we're gonna do the second order derivative. Okay, second order derivative is a derivative of the first order derivative. Right, so now we got our first order derivative and now we're gonna work on the second order derivative. And here, when I have a 3 as the common factor, I'm going to, simplify it. -1. Right? So I'm going to do the derivative, first order derivative of x plus h, which will be this piece, right? X plus h replaces x. Boom. And for convenience, we can put bracket just to make it easier for the reader to read, right? F of x is such, and we're ready to work on the numerator. So I'm going to work on the numerator, and that's f prime of x plus h, subtracting f prime of f of x. Right? 3 is a common factor. Factored out, right? So we got this piece subtracting that piece, factored out. Oh, sorry, right here. Right? We factored out the 3. So this piece subtracting x squared minus 1. There's a -1, sorry. There's a -1 there, right? There's a minus, this piece -1 subtracting x squared minus 1. So if I open up the parentheses here, the latter part, that's going to be +1, right? And now +1 and -1 makes 0. So this is gone. And then what? You can FOIL. You can FOIL or you can factor. Really, doesn't matter what you do. If you factor, if you like the factor, I like to factor, right? If you factor, you're going to have a plus b, a minus b, right? So x plus h minus x multiply x plus h plus x. And next, x minus x, that makes h. So this whole thing has only h left. And over here is 2x plus h. And that's just the numerator. So let's put in the limit and then put the limit and denominator, and we're getting second order derivative. Almost there. We are almost there. So the numerator is such. H and h reduced. What do we get next? Next, we are getting a reduced form. H is gone. Now we can do direct substitution. Replace h by 0, right? So 3 times 2x plus h, h replaced by 0, that's our limit, equals to 6x. To summarize, right, the second order derivative is equals to 6x. So that's how we find first order derivative and second order derivative by definition. Okay, so we get, to summarize, right, we got first order derivative, second order derivative, right? There's no domain issues. The function, where's our function? Our function is there. Our function is here. All right. The function, first order derivative, second order. So that's how we use definition to find them. Thank you for watching.